Awesome. Thank you so much. It's great to be here today and to talk a little bit about generative AI futures. This really feels like an unprecedented time in the machine learning space in the AI world. I started working on this around 2009, and it's never been cool before. So it's very, very interesting to have relatives back in Texas want to talk to me about that generative AI stuff. So excited to be here today to have a chance to kind of look under the hood a little bit at some of the companies that are building out this generative AI future, and to talk about some things in the open source world, in the large versus small model world, and then also some of the implications for on-device machine learning. Excellent. And so with that, I'm going to go ahead and kind of introduce our great panelists. My name is Paige. I work on generative AI at Google, particularly our large language models, our large generative models like Gemini. I have here with me today Adi. Do you want to give a brief introduction? Or?
Sure. So my name is Aditi Joshi. I work at Google. I've been there for 5 years. I focus on open source in our core ML group.
Excellent. And Kevin Schatz-Cameron?
Yeah, so another Googler. So I work in Google Cloud. I lead a team in our conversational and generative applied AI organization focused on agentic type things.
Awesome. And Sundara Rajan?
I'm at Microsoft. I lead a team on AI incubations here down the street in Kendall Square.
Wonderful. And then also Marcus?
Thank you. Thanks for hosting me. Yeah, Marcus Flödel. I lead the Intel Developer Cloud, and I'm building out very large supercomputers that are focused to host various startups, so established companies that are building a variety of large language models. Prior to that, I was at NVIDIA, built out NVIDIA's GPU cloud infrastructure.
Excellent. And so are you based locally as well?
Based in Silicon Valley.
Oh, gotcha. So we have a nice mix of Silicon Valley and Boston coming here today. And with that, I am going to get started. I also was not trusting the Wi-Fi connection, given how many people we have here in the audience and how many people we have in all of the hallway conversations outside. So we'll be reading some of the questions, and if we have time, we might take a couple of audience questions. But let's see how quickly we can get through these ideas. So first off, we've already discussed generative AI is kind of at a peak in the hype cycle that is unprecedented. Why do y'all think this might be the case today? And then Kevin, do you want to start?
Yeah, I'm happy to start. I think, in a past life, I spent a lot of time on this concept of digital transformation. That was like the big sledgehammer from top down of go transform, right? Reorganize yourself, be agile, and all these other things. And I think, obviously, it didn't work. I think that the reason it's at a hype cycle is because I think there's a subtlety to how it's getting adopted and integrated into applications and into general enterprise tasks and just everyday life. And it's not this big sledgehammer. It's just all of a sudden you start seeing these trailing indicators of improvement in efficiency or new things getting created or rate of adoption of new applications and services. And you kind of take that step back. Like, why is that happening? It's like, oh, Gen AI is under the covers. Right, software development, whatever we want to talk about. I think it's so integrated into tasks that the bottoms-up adoption is leading to a set of transformations and subtlety in just about every job role, and it's kind of neat to watch.
I think I can go next. I think the obvious answer is just compute. We have compute that's available to us, which allows us to do so much more than we could have ever done before. But I think what we're seeing now, and this was my lightning talk this morning, is how it's really changed how we launch products. And how has the role of an AI product manager really changed along the way, is the ability to be able to use these models, to be able to use the tools that are available through the use of AI for us as TPM co-pilots, your technical program manager, right? So when you're going from your MVP, your minimum viable product, to your product market fit from 0 to 1, it's a series of experiments that you're going through. That rapid experimentation is so critical in making sure that a product launch is successful. And I think that's what we're really going to see, our ability to transform the way that we launch our products and how fast we launch those products, incorporate the feedback that we're getting early into the process, and then keep iterating on that at a scale that's been, I think, unprecedented. I think that's just about to get started.
I love the sort of discussion around generating more interesting experiences in existing applications. Some of the places where we've seen the broadest adoption of AI features are in things like AI for software development.
Right.
So helping with things like code completion or code explanation in the context of an IDE, helping with burning down bugs or code review, and then also in our developer product or workplace productivity tools. So things like Microsoft Word or Google Docs, Sheets, Excel, really kind of meeting people where they are and trying to accelerate the tasks that people would have been doing anyway. So it's
Exactly.
really, really cool to see. Sundar Rajan?
I would say, I mean, what Khosla called it this morning, it's a ChatGPT moment. I think ChatGPT really showcased the ability for democratic access not only to technology but also opportunities. And it's also the fastest growing product in history of all products. So experimentation, rapid prototyping, all proved in a matter of like weeks to months. But that's a culmination of all the things that we are talking about, right? Like the technologies have been evolving, bubbling up to this moment. The mathematics have been bubbling up to this moment. And now the opportunity and access has basically become overnight available, and if not completely accessible in terms of cost yet. And maybe this is where the GPUs come in.
Indeed, very much so. We like people who use a lot of compute. That's for sure. Yeah, so I think at a high level, I think I'm always careful to try and predict the peak of the hike cycle. I mean, I've been around the block for a few years now, and I'm not sure it's the peak yet. I think anytime, if you take the analogy back to late '90s when I was in the cost of communication went down to near zero. I grew up at a time and I remember making a phone call and I was worried about people like how much it's costing me. My parents would scold me for being on the phone for too long. Growing up in Europe, a bit behind the US in that respect. But what's happening right now is also the cost of certain compute, of doing things in large language models, all of a sudden, certain tasks that you just couldn't afford. Maybe the compute was available before, but you just couldn't afford it. And all of a sudden, that compute is now available at the cost where it's just super attractive to automate certain functions. And I think it's not just the Moore's law that yes, you get more compute just from the hardware, but it's just that the rate at which these models are evolving and what you can do with the same amount of compute power is just mind-boggling. I was just listening into a talk by Naveen Rao last week at a Vision conference. He was talking about a factor 4 of improvement per year over year. So if you think about Moore's law, we've been trying to squeeze more out of the physical hardware, out of the compute, but you're getting twice the compute power every 18 months. What we're seeing now is that, yes, you still get more out of that compute, but the speed at which these algorithms are evolving is something like a factor 4, which means that if you're building a model today and you're spending $100 million building it, you just only care about reducing the cost, but it's also the speed, or the amount of effort it takes to build this maybe in a year from now could be something like a quarter of that. So the economics are just so mind-boggling, and the pace at which things are evolving is just so mind-boggling. It's incredible.
So I have a thought to add here, but I just want to ask, right? Is it like in the move to Intel that you're contractually obligated to name drop Moore's Law? is that
part of my job description, I apologize.
but aside from that, I think it's accessibility in general, right? Certainly compute matters, but just how accessible AI is because of large language models. We spend so much time thinking about the great things that happen on the output side. We tend to overlook how good large language models at understanding what I meant, right? The intent portion of it. To me, that's the most fascinating superpower of large language models and generative AI. It's great that we can build things with it, and there's a lot of outcomes with it. But just the fact that it understands human behavior and human intent and human speech, that's the fascinating part.
I love this conversation about accessibility and about how, huge pieces of the world who never had access to play with large language models are now being able to open up their browser and sort of use them for their experiments, use them as part of their work. I remember at Google when the first Palm models just came out, being able to test them out internally, being able to test out some of the image generation models, but having that all is just kind of like a sandbox within the context of the company. Whereas now, there's really massive potential for everyone in the world to start experimenting with these, to be able to understand how they could be creative and to accelerate this process of getting their ideas out into the world.
It's scary to think that was just about a year ago,
Just
isn't
about
it?
a year ago.
And how many iterations there's been.
Absolutely, and how much more efficient the compute has gotten. It's really, really awesome to see. And this is a great segue into our next section, which is all about open source versus closed source models. And I think all of the folks on the panel, have experience working with both. But really, open source models have massive potential for customization, adaptation. How have we started to see how open source is really driving some of the new features and the new excitement around these models? Adi, do you want to go first? I know that you work on a lot of really great open source projects within the context of Google.
Yeah, so I focus on OpenXLA, which is the middleware. So whether you use PyTorch or JAX or TensorFlow, we're offering a very open source middleware way to be able to access different hardware like Intel CPUs and GPUs and TPUs as well. So that's one aspect of it. But I think it's that collective wisdom that open source offers with the crowd, because not one company can do all of it, right? We're just a part of the puzzle. So working together as an ecosystem, I think that's really the critical piece of it that's going to help us to catapult to levels that we've never seen before.
Yep. Absolutely. Kevin, do you want to?
Yeah, I mean, look, our model garden supports 140-ish models, right? I think less than 20 of them are built by Google, and a large percentage of them are open source, coming through communities like Hugging Face and GitLab and various others. I think open source is a massively important part of this community, and I think, we've spent so much time in other segments of technology evolution, kind of thinking about the path from research to applied research towards production type use cases. And I think the gap between research, applied research, and production is pretty well near zero at this point. We're iterating so quickly and trying to get things out so quickly. So I think open source pushes closed source pushes open source. And every day, I come from a different background than AI. I spent 20 years in telecom, right? And I could probably take 2 to 3 years off in telecom and nothing changed. Here, you kind of take 2 to 3 days off, and state of the art looks different.
It's so true.
Speaking of which, if folks haven't already seen, Llama 3 got released today. So already available for folks to use, I believe, on Azure and also on Hugging Face. If you haven't had a chance to test it out, that's definitely something to take a look at. And then also, I love seeing how, as these open source models get released, they're increasingly pushing the boundaries in terms of model capabilities and performance, like the Mixtral models that just recently got released. And then also it sounds like the largest versions of Llama 3, they're surpassing even GPT-4 in capabilities these days. So it's pretty nifty. Do y'all want to add anything around open source, or?
Yeah, so I think there are two aspects to these differences. One is, as you mentioned, like from a developer perspective, you want to have a mixture. You want to provide as much variety at the right price point for all kinds of applications. So that's just the model perspective. But I think behind the hype, there's going to be this realization that we don't understand a lot of how these things work. And this is where the ability to leverage open source models is going to be a game changer. So research has now taken a backseat, to Kevin's point, because the ability for universities, for example, to continue to innovate and expand the science behind it is gated on access to certain GPUs, and there's sort of a cap to it, right? So open source is not only I think about it not only at the model level, but the entire up and down the stack that is helping not only to build new applications. Arvind talked about, like, okay, you want to get your first application out with a closed source model, and then you want to use fine-tuning with your open source model. So that's sort of one aspect of it. The other is, like, how do you understand where things fail, where things can get better? And the only place you can do that with is with open source.
I love that. When I was first learning how to do machine learning, I relied so much on all of the great resources that were put on GitHub, that were put online. And it was really only by reading the documentation and reading through others' code that I was able to learn about model internals. So I think if we lose that, and if the world just shifts to closed source models, then we've lost a really massive opportunity to help educate folks and to help build the next generation of research scientists. Marcus, do you want to?
Just to add to maybe just a few examples, I think if you go back in the history of software, it used to be a time when people used to pay for the browsers, the web browsers. There used to be a time when people paid for their operating systems in the data center, they paid for the databases, and they paid huge premiums. And it's just inevitable, I think, to all your points, it's just so much value to have a platform that everybody can contribute to, academia, students, startups, anybody that can contribute, that can improve it. I think for a single company to outdo that in the R&D is going to be really, really difficult, I think. And again, it doesn't mean in the short term it can happen. Again, there was many examples where it happened in the past. People built something that nobody had at that point in time, but then quickly somebody else started open sourcing. Llama 3 is a great example. All of a sudden you have the whole world starting to build around that, and it's very hard to keep up with that as a proprietary vendor.
I agree. And that's also a great segue into the next section, which is talking about small models versus sort of the larger models that we've seen on the most bleeding of edges. I think what we've seen in the community is that oftentimes people will take the smaller models. They might fine-tune them for specific tasks or use cases, and they're also obviously much more efficient to deploy, both from a latency perspective as well as a cost perspective, and also like a hardware footprint perspective. So if we wanted to discuss kind of the strengths and weaknesses of large and small models, what have y'all seen in terms of this within your own companies, and then also how you're thinking about this in terms of generative AI futures? Is it going to be one beating the other, or is it going to be a blend of both, as Sundar Rajan mentioned?
Yeah, I'll go then. I think it's going to be eventually a mixture. There is definitely now a shift a little bit towards a custom or fit-for-purpose type of SLMs. But another thing that maybe not many people know about SLMs is they tend to hallucinate a little less. And they seem to offer, like initial research is showing that they seem to offer better protection against harm content. So there is little other benefits to the SLMs than just the resources. But yeah, I think in the future it's going to be a mixture of all of the above.
Excellent. And for SLM, just for folks who might not be aware, is that small language model? Good. Excellent.
So I think it's interesting because maybe also about a year ago, there were a lot of conversations about large generalist models versus highly specialized models. I think actually Microsoft Research was one of the first to come out and say, look, you can take a really large generalist model and hyper-tune it, and it actually performs considerably better than some smaller models.
And just even prompt engineering
models, even prompt engineering as well. I think that's spot on, right? And I think we kind of lost sight, and a lot of the conversation was like, do I really need my model to understand the latest Taylor Swift songs? and it's not that, right? It's really the fact that it's trained on all of human language that matters in terms of understanding the intent to be able to execute against tasks.
Especially for the emergent capabilities. So there is also that concern with SLMs, that you need certain scale for the emergence capabilities to show up more prominently.
100%. But I do think it will be a hybrid world. I think on the small model side, some of the age-old techniques around RNNs are starting to prove really valuable to iterate and get high performance and high accuracy out of smaller models. And obviously, some of the things that are happening with mixture of experts are really driving down the latency of large models. So we're going to live kind of in a hybrid world for a long period of time. But once we solve the 10x compute problem, let's do everything large.
I love that you called out prompting strategies as well as retrieval methods. I think there are a lot of great ways to augment the capabilities of models without necessarily trying to bake in all of those smarts. Aditi?
I think it really depends on, open or closed, it really depends on what's the pain point that you're trying to solve for the customer at the end of the day. Is there a problem? Is there a pain point? And then what kind of product or solution do you want to be able to build? And then working backwards from there, depending on that particular use case. I think that's what's really critical in deciding whether it's open or if it's closed sourced or not. Now, there's advantages and disadvantages to both. Like if you use an open model, of course, it's available out there. It's rapid experimentation. Those are some of the pluses that you get with it. But again, the drawback may be the fact that quality control might not really necessarily exist, right? Or you have to build that in, and that takes quite some time it takes effort. And then from an open perspective, closed perspective, because they're large models, if you do want to build something that requires multimodality, then you want to start thinking about a closed model because it offers that multimodality, at least right now. So it goes back to, again, the pain point and the customer and the solution that you want to build for the pain point that they're experiencing.
And I think it's also really interesting too in the sense that there are some companies that are experimenting with releasing these much larger models as well as so making them Apache 2 licensed or making them licensed but only for academic use. In which case people can experience the coolness of multimodality and all of these other use cases, even though the models are open.
We had an awesome Gemma release yesterday on this.
Yep. Code Gemma or one of the other specialized versions?
One of the other specialized. Code Gemma also, but there was another.
Cool. Excellent. And Marcus?
First of all, we like all language models, so long as they're on Intel hardware. We're happy. Aside from that, no, I think there's just, and I think this sort of bleeds into the next discussion. I think the next question you teed up about, what runs on the client versus what runs on the server. And I think, just simple things like, at some point, just economics will dictate that. Let's take a Copilot as an example. When I run a Copilot, as a startup, I want to give out a Copilot. If I can run this on the client, if the client has enough compute power to do that, I can just offer this as a free service and still be not lose too much money. If I try to do this on the server side, it's just going to bankrupt me. So, and vice versa, if that same user then comes and says, I want to turn on all these other new features, great, I can then provide them with additional compute power in the cloud, and I can augment that, and all of a sudden they get a much higher level of service, and maybe it's going to cost them $100 or something a month, but now it's a professional developer that can afford that. So I think the hybrid of those two is ultimately what's going to dictate that. So I don't think it's one or the other, it's one and the other.
Awesome. And one of the most interesting patterns that I've seen in the generative AI space is having kind of a larger model be the planner model, and being able to kind of take in a high-level task, break it into subcomponents, and then be clever about which model to assign to which of those subtasks. So it might be that for one of the subtasks, you need a model that's a little bit more impressive, perhaps a little bit more expensive, needs to do its computation on the server side, but then for others you can use a much more small kind of model locally, or even tools that might be available locally, as opposed to relying too much on model smarts. And to y'all's points, that breaks down the cost, makes the latency go down as well, because you're not sending everything out into the world, and it also means that at the end of the day, your users are getting a much better experience.
I think this is going to drive a lot more compute power locally on the client also, because certain of these things you just can't afford you just can't afford them as a SaaS provider. It's just too expensive.
That doesn't look good. It looks like we're about to get cut off.
Oh wow, John, are we getting cut off? Okay, excellent. Well, so I apologize. It looks like we got too excited about the conversation. Though I think we had a really great discussion about the strengths and weaknesses today of generative models. If I could just ask one more question to everybody, very quick, one sentence only, top of mind, rapid fire. What are you most excited about for the next year of generative models, given everything that's happened in this past year?
Sure. I'm excited about all the tooling that's surrounding it and bringing those capabilities to every user.
Excellent.
Yeah, I think just the new use cases that we're going to be seeing. I mean, there's just so much innovation going on. Talking to so many startups, it's just fascinating, the speed at which things are evolving. Again, back to the late 90s, once you have cost of communication set down to zero, all of a sudden you see people, placing the Ubers and all these things. None of that existed. So I think we'll see something similar over the next year or the next few years.
Awesome.
I think AI allows us to be much more rigorous and disciplined in our experimentation approach, and I think that's going to revolutionize how we build products.
I think it's learning for me, right? When I stepped into this event and I saw everyone here and I started to listen to a number of the sessions, it became clear to me that I know a fraction of a percentage of what's actually happening in AI right now.
Excellent. So it sounds like generative AI is going to be even more exciting. Perhaps we're not at peak hype cycle just yet. We have a little bit of ways to go. And we should all be excited about what's yet to come. So thank you so much. Thank you to our panelists. You all did a great job.